Hey, what's up guys? In this video, I'm going to introduce to you how to rationalize the denominator of a numerical fraction. Alright, here it is. So here we have a fraction, 1 over the square root of 10, and this denominator here, the square root of 10, is what we call an irrational number, which means if you were to type in the square root of 10 into a calculator, then you would end up with a non-terminating, non-repeating decimal. So what it means to rationalize the denominator is to rewrite this fraction in a way where the denominator is not an irrational number. So how we do that is we need to get rid of the radical from the denominator. So the trick we use to do this is I can get rid of this radical here by multiplying the denominator by the square root of 10, because the square root of 10 times the square root of 10 equals 10. So that will essentially undo the radical. But I can't just multiply the denominator without changing the value of this fraction. So in order to maintain equivalence here, I also need to multiply the numerator by the same thing, because the square root of 10 divided by the square root of 10 is just 1. So you can think of it as multiplying this fraction by 1, which obviously doesn't change the value, but it will change what it looks like. It'll change the expression. So again, I strategically want to multiply the denominator by root 10 so that I'll undo the radical in the denominator. But since I'm doing that, I also need to multiply the numerator by root 10 to maintain equivalence. And if you need an illustration as to why we're allowed to do that, imagine you just had like a simple fraction like 1/2, right? I can multiply the top and bottom, the numerator and the denominator, by the same number, 2 in this case, and I end up with 2/4, which we know is equivalent to 1/2. So again, by multiplying by 1, something divided by itself, I don't actually change the value of the fraction. So what happens when I do this? Well, how we multiply fractions, we just multiply the numerators. So 1 times root 10 is simply root 10. And again, root 10 times root 10 is just 10. So as you can see, I have written an equivalent fraction to 1 divided by root 10, but now my denominator is no longer irrational. My denominator is a rational number, it's 10. Okay? And you might be asking yourself, what's the point of even doing this? This doesn't look any better than this one does. And I wouldn't disagree with you, but the more complicated the expressions get and the more complicated your problem gets, sometimes you might have to add or subtract fractions, in which case having an irrational denominator makes that a bit uglier. So in the long run, this is a worthy skill to learn. Okay, so I'll do a few more. I'll do another pretty simple one, and then we'll move on to some more complicated ones. Okay, so imagine we have 2 divided by the square root of 3, and I want to rationalize the denominator. So I will multiply the bottom, the denominator, by root 3. Okay, the same thing, because again, root 3 times root 3 will give me 3, so I'll undo the radical that way. But I have to pay the price. I can't just multiply the denominator. I also need to multiply the numerator by the same amount. Okay, and now 2 times root 3, we can simply write as 2 root 3. And then, like I said, root 3 times root 3 is 3. Okay. All right, and now we'll ramp this up a little bit. Imagine we have something like 4 divided by the square root of 20. So the process starts the same way. I'll multiply by root 20 over root 20. And now 4 times root 20 is 4 root 20. And root 20 times root 20 is 20. Now, my denominator is rationalized now, but this is not fully simplified. Okay, so the square root of 20 is not simplest radical form, so I can actually simplify this further. So what I'm going to do is I'm going to rewrite the numerator as I'm going to keep my 4, but now I'm going to factor the square root of 20 into the square root of 4 times the square root of 5. Okay? So again, all I did was I rewrote this exact same expression, except I factored root 20 into root 4 and root 5. And the reason I did that is because 4 is the largest perfect square that goes into 20. So I'm going to kind of assume you're pretty comfortable with simplest radical form at this point. So I'm going to move through this part kind of quickly. But now I know that root 4 is just 2. So I have 4 times 2 times root 5 all over 20. Okay, that simplifies to 8 root 5 over 20. And now I can simplify 8 divided by 20. 4 goes into 8 twice, and 4 goes into 20 5 times. So I can fully simplify this to 2 root 5 over 5. Okay, and again, the 2/5 comes from the simplified version of 8 over 20. Okay, we'll do one more. Seven over the square root of 27. So to get the to rationalize the denominator here, I will multiply the numerator and denominator by root 27. And again, root 27 is not simplest radical form, so I will factor root 27. The largest perfect square that goes into 27 is 9, so I'll factor this into root 9 times root 3, because 9 times 3 is 27. And I can simplify the root 9, I know that's 3. And I can do my multiplication. And now I can simplify 21 over 27. 3 goes into 21 7 times, and 3 goes into 27 9 times. And so my simplest radical form here would be 7 root 3 divided by 9. Okay, and with that said, it's been demonstrated.